Okay, so we've used this terminology feedback very often by now, and you have a very good sense of it. So let's try to formally define it here. Okay, so let's look at an example of a positive feedback and a negative feedback, and then say how the net feedback of a loop is understood. Not always possible, but nonetheless, just to have the concept is good. So here is an example. Let's say some perturbation makes the atmospheric temperature warmer. Let's say it's increased CO2 or orbital forcing or whatever. Warmer temperatures means atmosphere can hold more moisture. That would increase evaporation. Water vapor is a greenhouse gas, so that would trap more outgoing long-wave radiation and make the atmospheric temperature even warmer. So you have more evaporation, more water vapor, more warming. So the initial perturbation is now amplified by this feedback loop. Hence, this is a positive feedback loop. Okay? Whereas if the increased evaporation and the water vapor in the atmosphere formed clouds, and the clouds started to reflect the radiation, solar radiation, back to space, then that would damp the initial perturbation that created the warming. So the warming happened because of some perturbation in greenhouse gas or orbital forcing. It increased evaporation and water vapor. Water vapor formed clouds. Clouds increased the albedo and increased the loss of shortwave and reduced the initial warming. That's a negative feedback. So formally talking about such feedback loops is done by couplings and feedbacks. So think of an example where, let's say you're living in a cold country and you need an electric blanket to stay warm at night during a winter. The blanket temperature is coupled to the body temperature such that if the blanket temperature goes up, the body should feel warmer. So that's shown with an arrow, so that's a positive feedback. The design is such that if the blanket temperature goes up, then the body temperature should let's do it the other way. If the body temperature goes up and it gets too warm, the blanket temperature will be reduced. So that's a negative coupling. This is just coupling between the blanket temperature and the body temperature, right? If you put them together, because that's the system, you're going to put on the blanket and you have a control. So the body temperature, if it gets too hot, is going to you're going to reduce the blanket temperature, or you're going to set a thermostat which controls the temperature, right? Let's say you set it to a nice and warm 72 degrees Fahrenheit, however many degrees centigrade that is. If the body temperature goes above that and the air within the blanket becomes too warm, thermostat will turn down the blanket temperature, and that would turn down the body temperature. So you have a negative feedback and a positive feedback. To get the net feedback of this loop between the body temperature and the blanket temperature, you multiply all the feedbacks in the loop. You have one negative and one positive, so you have a negative feedback. So it's a stable network, stable feedback. Obviously you want that, right? The refrigerator, the air conditioning, the heating in the room, they are all thermostat driven. They are stable negative feedback loops. That's what you want. Okay, you don't want runaway warming or cooling there. This is not just a joke, right? So here is an example of actually what happened in 1980 when a guy called Jimmy Carter got elected to be the president of the United States. Very nice guy, and did some good things for the environment by installing solar heaters on White House and so on. Nonetheless, he and his wife were given a big electric blanket, but inadvertently the thermostats were switched around, so each person could control the temperature on their side of the bed, their side of the blanket. But because the thermostat was switched, when Rosalind, his wife, felt cold, she would try to crank up the temperature of the blanket on her side, but the temperature on Jimmy's side would go up and he would go crazy and try to turn down the temperature, the temperature would go down on Rosalind's side. So she would get colder and she would try to crank up temperature on Jimmy's side. So you can see that the two loops were both negative, but they were mixed up to create a net positive loop because of this thermostat being switched around. Okay, so obviously it's a runaway situation. They ended up fighting, called the engineer, and the engineer figured out that actually there was a screw up, so they fixed it. Maybe they played a joke on it, but nonetheless, that's what happens. In the real world, you cannot always find such nicely defined loops because many things tend to be related to each other. Here it is looking at the impact of runoff of nutrients onto forest and its impact on the albedo and energy balance, atmospheric CO2 and its impact on temperature, evapotranspiration, and so on. Each one is related to the other. Okay, let's say a agricultural field was created nearby which increased the nutrient supply into the rivers, and the rivers supplied more nutrients to the forest. Forest would respond positively and affect the CO2. More forest cover means darker surface to the sun, so albedo would go down. That would trap more energy, that would increase the temperature. CO2 would also have an impact. They both affect how much energy loss happens from the trees or how much moisture loss. Remember, the stomata have to open to capture CO2 from the air, but they have to preserve the water that's being pumped up from the roots up the capillary tubes to the leaves, right? So that balance is going to be affected by changing the temperature, water vapor, and so on. And that would affect the runoff because how much water vapor, water is taken up by the roots or rejected by the roots is going to affect the runoff into the streams nearby. This is a serious issue. Trees actually can affect the hydrologic cycle as well. Okay, and the evapotranspiration can affect the microclimate and the local rainfall, clouds, and so on. So it's not easy to define the net feedback of the loop here. You can look at smaller loops and say this part is positive, this part is negative, and so on. But nonetheless, I hope you get a sense of what we mean by feedbacks, positive feedbacks and negative feedbacks. So then the question is global warming a positive feedback, a net positive feedback? What are the things, what are the feedbacks in the system that can amplify the perturbation we are making, and what are the feedbacks that can damp the perturbation we are making? This is what we need to be aware of to be able to make sure that we're not going to put the system into a mad runaway. And we'll see that in fact some things are already on a runaway irreversible state. Okay?